This calcium atom moves outward by alternate jerks of forward propulsion, grasping and letting go the sunbeam about 25,000 times each second. And this is why stone is the chief component of the worlds of space. Calcium is the most expert solar prison escaper. The agility of this acrobatic calcium electron is indicated by the fact that, when tossed by the temperature X-ray solar forces to the circle of the higher orbit, it only remains in that orbit for about 1/1,000,000th of a second, but before the electric gravity power of the atomic nucleus pulls it back into its old orbit, it is able to complete 1,000,000 revolutions about the atomic center. Your sun has parted with an enormous quantity of its calcium, having lost tremendous amounts during the times of its convulsive eruptions in connection with the formation of the solar system. Much of the solar calcium is now in the outer crust of the sun. It should be remembered that spectral analyses show only sun surface compositions. For example, solar spectra exhibit many iron lines, but iron is not the chief element in the sun. This phenomenon is almost wholly due to the present temperature of the sun's surface, a little less than 6,000 degrees, this temperature being very favorable to the registry of the iron spectrum. 7. Sources of solar energy. The internal temperature of many suns, even your own, is much higher than is commonly believed. In the interior of a sun, practically no whole atoms exist. They are all more or less shattered by the intensive X-ray bombardment which is indigenous to such high temperatures. Regardless of what material elements may appear in the outer layers of a sun, those in the interior are rendered very similar by the dissociative action of the disruptive X-rays. X-ray is the great leveler of atomic existence. The surface temperature of your sun is almost 6,000 degrees, but it rapidly increases as the interior is penetrated until it attains the unbelievable height of about 35 million degrees in the central regions. All of these temperatures refer to your Fahrenheit scale. All of these phenomena are indicative of enormous energy expenditure, and the sources of solar energy, named in the order of their importance, are 1. Annihilation of atoms and, eventually, of electrons. 2. Transmutation of elements, including the radioactive group of energies thus liberated. 3. The accumulation and transmission of certain universal space energies. 4. Space matter and meteors, which are incessantly diving into the blazing suns. 5. Solar contraction. The cooling and consequent contraction of a sun yields energy and heat, sometimes greater than that supplied by space matter. 6. Gravity action at high temperatures transforms certain circuitized power into radioactive energies. 7. Recaptive light and other matter which are drawn back into the sun after having left it, together with other energies having extrasolar origin. There exists a regulating blanket of hot gases, sometimes millions of degrees in temperature, which envelops the suns, and which acts to stabilize heat loss and otherwise prevent hazardous fluctuations of heat dissipation. During the active life of a sun, the internal temperature of 35 million degrees remains about the same, quite regardless of the progressive fall of the external temperature. You might try to visualize 35 million degrees of heat in association with certain gravity pressures as the electronic boiling point. Under such pressure and at such temperature, all atoms are degraded and broken up into their electronic and other ancestral components. Even the electrons and other associations of ultimatons may be broken up, but the suns are not able to degrade the ultimatons. These solar temperatures operate to enormously speed up the ultimatons and the electrons, at least such of the latter as continue to maintain their existence under these conditions. You will realize what high temperature means by way of the acceleration of ultimatonic and electronic activities when you pause to consider that one drop of ordinary water contains over 1 billion trillions of atoms. This is the energy of more than 100 horsepower exerted continuously for 2 years. The total heat now given out by the solar system's sun each second is sufficient to boil all the water in all the oceans on Urantia in just 1 second of time. Only those suns which function in the direct channels of the main streams of universe energy can shine on forever. Such solar furnaces blaze on indefinitely, being able to replenish their material losses by the intake of space force and analogous circulating energy. But stars far removed from these chief channels of recharging are destined to undergo energy depletion, gradually cool off, and eventually burn out. Such dead or dying suns can be rejuvenated by collisional impact, or can be recharged by certain non-luminous energy islands of space, or through gravity robbery of nearby smaller suns or systems. The majority of dead suns will experience revivification by these or other evolutionary techniques. Those which are not thus eventually recharged are destined to undergo disruption by mass explosion when the gravity condensation attains the critical level of ultimatonic condensation of energy pressure. Such disappearing suns thus become energy of the rarest form, admirably adapted to energize other more favorably situated suns. 8. Solar energy reactions. In those suns which are encircuited in the space energy channels, solar energy is liberated by various complex nuclear reaction chains, the most common of which is the hydrogen-carbon-helium reaction. In this metamorphosis, carbon acts as an energy catalyst, since it is in no way actually changed by this process of converting hydrogen into helium. Under certain conditions of high temperature, the hydrogen penetrates the carbon nuclei. Since the carbon cannot hold more than 4 such protons, when this saturation state is attained, it begins to emit protons as fast as new ones arrive. In this reaction, the ingoing hydrogen particles come forth as a helium atom. Reduction of hydrogen content increases the luminosity of a sun. In the suns destined to burn out, the height of luminosity is attained at the point of hydrogen exhaustion. Subsequent to this point, brilliance is maintained by the resultant process of gravity contraction. Eventually, such a star will become a so-called white dwarf, a highly condensed sphere. In large suns, small circular nebulae, when hydrogen is exhausted and gravity contraction ensues, if such a body is not sufficiently opaque to retain the internal pressure of support for the outer gas regions, then a sudden collapse occurs. The gravity-electric changes give origin to vast quantities of tiny particles devoid of electric potential, and such particles readily escape from the solar interior, thus bringing about the collapse of a gigantic sun within a few days. It was such an emigration of these runaway particles that occasioned the collapse of the giant nova of the Andromeda Nebula about 50 years ago. This vast stellar body collapsed in 40 minutes of Urantia time. As a rule, the vast extrusion of matter continues to exist about the residual cooling sun as extensive clouds of nebular gases, and all this explains the origin of many types of irregular nebulae, such as the Crab Nebula, which had its origin about 900 years ago, and which still exhibits the mother sphere as a lone star near the center of this irregular nebular mass. 9. Sun stability. The larger suns maintain such a gravity control over their electrons that light escapes only with the aid of the powerful X-rays. These helper rays penetrate all space and are concerned in the maintenance of the basic ultimatonic associations of energy. The great energy losses in the early days of a sun, subsequent to its attainment of maximum temperature, upwards of 35 million degrees, are not so much due to light escape as to ultimatonic leakage. These ultimaton energies escape out into space to engage in the adventure of electronic association and energy materialization, as a veritable energy blast during adolescent solar times. Atoms and electrons are subject to gravity. The automatons are not subject to local